So today we're going to be talking about some of the basics and the fundamentals of trigonometry. So we have these three fundamental ratios that you need to understand to be successful in any trigonometry-based class, whether that's actual trigonometry or physics or anything involving right triangles and triangles in general, and angles in general as well. So we're given an acronym, and this acronym is called soh-cah-toa. And this is pretty important to remember if you want to know what the trigonometric ratios are by heart, and you will in time once you practice more. So we have this thing soh-cah-toa, S being sine, the C being cosine, and T being tangent. Those are the three major ratios that you need to know. So sine is nothing more than the ratio in any given triangle of, let's say we have right triangle right here, and this is, let's just say that's A, B, and C. Sine is nothing more than a ratio of opposite, I'm going to abbreviate it op, over hypotenuse. I'm going to abbreviate it HYP. That's pretty simple, right? So if we're given angle theta right here, that would be, if we had sine theta, angle being, the theta being in degrees or radians depending on the problem, we would have opposite, so opposite over hypotenuse, which is A over C. So that's fairly simple. Next we have A over C. Sorry. Next we have cosine, which is nothing more than adjacent over hypotenuse. So adjacent, I'm going to abbreviate it ADG, over hypotenuse. So just a quick recap. You should know by now that a hypotenuse in a right triangle is simply the longest side in the right triangle. So for our case, C would be the right triangle. Or sorry, C would be the hypotenuse. So adjacent, and all adjacent means is just like next to. So think of adjacent as the side next to the angle, aside from the hypotenuse. So if we have angle theta, adjacent would be right there, and then hypotenuse would be right there, right? So that would, if we had cosine theta, we would have B over C, right? So let me get rid of that. 1 second, guys. So yeah, cosine theta equals B over C. Finally, we have this thing called tangent. And tangent is sort of a combination of the two. Now, I shouldn't say combination, but you'll see in a second. Tangent is simply opposite over opposite over adjacent. So, in our case, if we had tangent theta, that would be A over B, right? Now, tangent is also, it's opposite over adjacent, but you will learn that it's also another thing, which is basically, it's basically the same thing, but it's also another thing, if that makes sense. So you'll also learn it to be sine theta over cosine theta. It's the same thing, equals tangent theta. And if we actually work this out, so I open up a new tab here. So if we have sine theta over cosine theta, let's think about this. We know that tangent theta, first of all, is opposite over adjacent. Okay, that makes sense, right? So that's, in our case, let's see. Actually, never mind. So we have sine theta over cosine theta. We know that sine theta is opposite over hypotenuse. And we know that cosine theta is adjacent over hypotenuse. Adjacent over hypotenuse. So if we're actually dividing these if we do sine theta divided by cosine theta, and since they're fractions, all we're going to do is take the first one and multiply it by the reciprocal of the second one. And what does reciprocal mean? Reciprocal is nothing more than just flipping the numerator and the denominator. So what we're going to do next is opposite over hypotenuse times the reciprocal of adjacent over hypotenuse, which is simply hypotenuse over adjacent. And then this is basically how we get opposite over adjacent. Is how we get that in the first place. So the hypotenuses cancel out, and then we're left over with opposite over adjacent. So that's just kind of a proof that sine theta over cosine theta will equal tangent theta. Alright guys, so this is going to be our first practice problem here. And what we're going to do is, well, we're given a right triangle here, right, with known side 2, known angle 30 degrees, and unknown sides A and B. Now what we could do is we could solve for the angle, the third angle right there, since we know that this is a 90 right here. As you can see right here, it's a 90-degree angle. That's a 30-degree angle, and then I would just leave that as a 60-degree angle, although we don't really need to do that right now. It's not necessary, but you could actually solve for that angle and use that angle instead to solve for A and B. But for now, we're just going to use the 30-degree angle. So we're going to find A first. What we're going to do here, as we can see, A is opposite of 30, right? So we're going to use sine. So we're going to have sine 30. Sine 30. And we're going to set that equal to opposite over hypotenuse, right? Which is A over 2. And all we're going to do here, guys, is we're going to isolate the A. So we're going to multiply both sides by 2. And we end up getting A equals 2 sine 30. Now, I want to point something out. I do not want you guys writing this as A equals sine 30 times 2, because that may or may not be incorrect. Because what this looks like to me, or a professor or a teacher or maybe a college board grader, that might look like sine of 30 times 2, which would be sine 60. And we don't want sine 60, we want to use sine 30 and multiply the result of that by 2. So it would be much easier if you just write it in the beginning. So sine 30 would be much easier, and it would not confuse your calculator. Next thing, since I haven't really gone over trig identities yet, this is a basic one. I already know the trig identities. I could basically do this one in my head. But for now, I want you to grab your calculator, either scientific or graphing, turn it on. Number one, I want you to make sure it's in degree mode. So if you have a TI-84, that's the one I have, you're going to go to mode, which is the button to the right of second, the blue button, one button next to the blue button, sorry. Make sure that's in degree mode. I don't know if you have a scientific calculator, I'm not sure if it's, maybe it's always in degrees. I don't remember, I haven't used a scientific calculator in forever, but just make sure it's in degree, and if you don't know, double check online. And then basically you're just gonna punch it in. So 2 times, you could either hit the times or you don't necessarily have to, because it's just implied that it's multiplication. So 2 sine 30, and you're going to get 1. So A would equal 1. That's pretty simple. So next we have, what are we looking for? We're looking for B, right? We're gonna use the same angle in this case. What we could do, actually, we could also use Pythagorean theorem. But we're not doing that right now. It might be easier if you use Pythagorean theorem, but we're focusing on trig ratios right now. So now we're looking for B, and since B is adjacent to 30, we're going to use cosine. So we're going to do cosine 30, right? So cosine 30 is equal to adjacent over hypotenuse, which is B over 2. We're going to isolate the B, multiply by 2 on both sides, basic algebra stuff, and then we're going to get B is equal to 2 cosine 30. And then you're going to simply put that into your calculator, and you should get radical 3, which should be around 1.7, I believe. Let me double check that. 2 cos 30, rad 3, Yep, that was correct. 1.73-ish. But yeah, these are your answers. So A is equal to 1 and B is equal to 1.73 roughly. Alright guys, so now we're going to do this triangle right here together. And then after that, I'm going to give you one more problem to actually go through on your own and see if you get it right. But, yeah, let's get to this really quickly. We're going to do this really quickly. I don't want the video to be too long. So first we're going to find B, alright? So we're going to use, since that's adjacent, what we want to use, we have the opposite. So what we want to use is tangent. So if we do tangent 42, we'll do this quick, equals 4 over B. So now what we do is we multiply, so like the previous problems, what we did is we multiplied the number on both sides, but in this case, the variable is actually in the denominator, so what we're going to do is we're going to multiply both sides by b, and then we're going to divide both sides by tangent 42. So first, we're going to do both sides by b, we get b tangent 42 equals 4, and then divide both sides by tangent 42, you get b equals 4 over tangent 32. Now, when you put that in your calculator, I would, just to be sure, put parentheses around it, and what you end up getting is, I'm going to do that real quick, 4 divided by, actually you don't necessarily need the parentheses, but sometimes it's necessary, but for now it's not. What you end up getting is around 4.44 as your answer. And then now we're going to do the second part. We're going to find C. I would definitely recommend using sine for this one instead of cosine. We do have B now, so we could use cosine if we wanted to, but I would definitely recommend using sine instead, because this opposite right here, this opposite side is actually more accurate, because this right here is actually an approximation. We rounded, right? Yeah, I rounded to the nearest hundredth. So now we're going to do sine 42. So sine 42, I'm going to divide that actually. Sine 42 is going to equal 4 over c. We're going to do the same process, to multiply both sides by c, divide both sides by sine 42, and you end up getting sine over 4 sine 42, which is 4 divided by sine 42. You end up getting approximately 5.98. So C is about, we'll say C is about 5.98. And that is your answer. Alright, and we're on our final problem, and I'm going to have you guys do this one. I'm going to have you pause the video and then unpause it to check your work. And yeah, so go ahead and pause the video, do it on your own, and then check what I get. Alright guys, so this is the correct answer. If you did not get that, then go ahead and double check your work, follow my steps. Rewind the video if you have to see if you've missed anything. If you did get it, then great job, good for you, and you're on the right track. So thanks guys for watching, hope this helped, and I'll see you next time.